Hello everyone, this is Mohammad Inayatullah from the SAIMEDHA coaching center, Koti, Hyderabad. So as we all know, Polytechnic lecturers notification has been released. So SAIMEDHA Koti, Hyderabad is giving the online coaching for the civil, EC and the EEE students. Okay, so SAIMEDHA Koti, Hyderabad will be giving the complete online platform for the Polytechnic lecturers. Okay, so in this video we are going to cover a small topic and the important topic related to the strength of materials, which is for civil students. Okay, so first we will discuss about the concept of the topic, mechanical properties, which will be very important in this strength of materials, and the different subjects for the civil engineers also. So first we will discuss the concept. Now using that concept, we are going to solve the questions related to the GATE questions, ESC questions, TSPSC, APPSC and the other state questions also. Okay, so first we will discuss about the concept over here. So first what we are having, mechanical properties. We will discuss about mechanical properties. So all this mechanical properties of a material, this will be coming under our first chapter. What we are having, first chapter, simple stresses and strains. So whenever we want to start that chapter, simple stresses and strains, we should know the information related to the what? Mechanical properties. Okay. Now in this mechanical properties, actually first part what we are taking means, we are taking it as elasticity. Now what is the meaning of elasticity? What is the meaning of elasticity? Listen here carefully. So I'll write the definition over here. What's the meaning of elasticity means? The ability of the material, or else we can write it as a body also. The ability of a material or body which changes to original shape, or size after removing the applied load. Okay. Now what is the meaning of load over here? We are having some different types of loads. Tensile load will be having, compressive load will be having. Okay. Suppose we have taken a body like this. So when we have taken a body, now what we are doing means, we are applying the tensile load. What is the meaning of tensile load actually? Whenever we are applying the loads on both the sides over here, tensile load we are having. Now what is the meaning of tensile? If we want to pull this body from the two sides, whenever we are trying to what? Whenever we are trying to pull this body, so it is coming under what? Tensile load. Whenever we want to push this body from the two sides, whenever we want to compress this one, pushing this one from the two sides, it is coming under what? Compressive load. Okay. So which load we are applying over here? Tensile load. So whenever we are applying the tensile load means, what will happen generally? There will be increase in the length of the body. Okay. You have to remember like this. Whenever there is an increase in the length of the body, it is nothing but what? Tensile load we have applied. When there is a decrease in the length of the body, which load we have applied? We have applied the compressive load. Okay. So whatever the load we are applying, actually either it is tensile or else compressive. Whenever we are applying the load, so there is some changes in the body, either it is increase or decrease. So whenever we are having the changes, after that what we are doing means, if we are removing that load, whenever we are removing that load, that body, that material, it is coming back to the original shape or original size. Okay. So after removing the load, whenever the body is coming back to the original shape or size, that property we are calling it as what? Elasticity. What we are calling that property? We are calling it as elasticity. We can take the examples over here. Which example we are taking? The example we can take it as rubber. We can take it as a rubber, we can take it as a spring, we can take it as a steel actually. Okay, this number of examples we can take. Suppose if you are taking the rubber band actually, okay, rubber band if you are taking means what we are doing, whenever we are applying the load over here, tensile load we are applying, so what will happen? There will be increase in the length of that rubber band actually. Yes or no? But whenever after some time, if you are removing that load, what will happen? It is coming back to the original position. Okay. So this is what we are calling this property as elasticity. So what we can write examples? We can write it as rubber. We can write the examples as rubber, or else steel also we can write. Okay, number of examples we can write, etc. Now we are having one most important point over here. This question has been asked in most of the competitive examination. What is that question means? If you are comparing this rubber or steel, we have taken some number of options is given, 4 options is given. Now it has been asked which material is more elastic. Which material is more elastic? So what we can say directly, we have seen the experiments of the rubber many times. Yes or no? So we'll give the answer as rubber. But if you are considering this rubber and steel, means steel will be more elastic than the rubber. What we are having the most important point over here, most important point we are having it as steel will be the steel is more elastic. Steel is more elastic than rubber. Steel is more elastic than rubber. Okay, note this point. This is very important. Steel is more elastic than rubber. Now how we can say that the steel is more elastic than rubber actually? Because whenever we are taking the rubber and we are applying some load, we are applying some force on that, it is changing. Okay, it is changing. Now after removing of that load, it is coming back to the original shape. Okay, now we'll take the example of the steel actually. Okay, so many times you have seen the steel scale actually. Steel scale you have seen. So in your childhood, in your school days also you have used the steel scale actually. So that steel scale if you are using, and if you are bending that steel scale like this, what will happen? If you are applying the load, means it will be like this, it will be in the bending condition. Now whenever we are removing that load, it is coming back faster than the rubber to the original position. Understood? What is happening? Whenever we are applying the load on this steel scale like this, means it is bending. It is bending. After removing of the load, what will happen? The steel scale will be coming back like this in the original position. So if you are comparing the steel as well as the rubber over here, so which one is coming faster? The steel will be coming faster if you are comparing with the rubber. Understood? So what is happening over here? If you are considering this one, steel is more elastic than rubber, how we have decided this statement means which one is coming faster to the original position, rubber or else the steel. So we can decide that, we can come to a conclusion that steel will be coming faster than the rubber. That's why we have said that the steel is more elastic than rubber. Understood? One more definition, one more point will also be, we can say that rubber, we are having the more strain actually. Whenever we are applying the load, we are having the stress. Due to that stress, we are getting more strain. If you are having more strain, then that will be what? Somewhat less elastic. If you are having the less strain, this steel will be having the less strain actually. So if it is having less strain, what is happening? It is coming back to the original position faster than the rubber. If it is coming faster, means what we have decided, we came to conclusion that it will be more elastic than rubber. This point is very much important. Okay, so this was about elasticity. Elasticity we have taken. Now coming to plasticity. Now what is the meaning of plasticity over here? So in this, actually what we have written, the ability of a material which changes to original shape or size after removing the applied load. Over here what we have tried, the ability of the material, which cannot regain its original shape or size. Its original shape or size. Okay, after removing the applied load, after removing the applied load. Okay, so this part we have written the definition for plasticity. Elasticity, the ability of the material which changes, or else we can write it as regains also. Okay, we can write over here as a regains, changes or else regains to original shape or size after removing the applied load. Now in this part what we have taken, which cannot regain to its original shape or size after removing the applied load, this part we are calling it as what? Plasticity. So that same example we are taking over steel scale. Steel scale example we have taken. If you are bending up to some limit, actually up to some limit, if you are bending like this, means whenever we are removing the load, what is happening? It is coming back to the original position. That is what elasticity. Now again and again, whenever we are increasing the load after some limit, what will happen? It will loses the elasticity property and it will be coming into what? Permanent deformation. Means after increasing the load, what is happening? It is not coming back to the original position. If it is not coming back to the original position, actually it will be coming under what? Plasticity. Means we are having the permanent deformation over there. If we are having permanent deformation, that steel, it is not coming back to the original position. Okay, so whenever it is not having the capability to regain its original shape or size, we are calling it as what? Plasticity. Okay, this part is completed. Now next, let us go for strength. What is the meaning of strength actually? Strength. So what is the meaning of strength? Means ability of the material, to resist external loads, before breaking. Now what is the meaning of this part now? Ability of the material to resist external loads before breaking. Now what will happen means, whenever we are, suppose this is a body we have taken, this is a material. Now whenever we are applying the loads on this, whenever we are applying the external loads externally outside, so whenever we are applying some external loads on this body or material, what is happening? This body, it is having the capacity to resist that external loads before breaking. Means what is happening over here? So whenever we are applying some loads, what is happening? There will be some deformation. But it is not breaking. Okay, it is resisting that external loads before breaking, actually before breaking point. So it is absorbing, it is resisting all that external loads and it is making that material or else the body to not break. Understood? So what we have taken? Ability of the material to resist the external loads before breaking. Now we are having one more property which will be similar to this strength over here. That is called as stiffness. Listen here carefully. What is the meaning of stiffness now? So it will be similar to strength only. So ability of the material, to resist deformation under stress. Now what is the difference between this strength and stiffness? Listen here carefully. So stiffness means what we have written? We have written this resisting the deformation itself. So it is having the ability of the material to resist the deformation. Now what is the meaning of deformation? Actually deformation means the body is changing its dimension. Either it will be increase or decrease in the length or its diameter, whatever the dimension we are having. Whenever we are having the changes in the dimension, we are calling it as what? Deformation. So stiffness means the ability of the material to resist the deformation. But what is the meaning of strength over here? we are having the deformation in this, we are having the deformation, there will be deformation in the body, but after deformation it is resisting from what? Breaking point. It is resisting from what? Break point, rupture, failure. It is resisting from that point. Over here in the stiffness, what is the ability of the material? To resist the deformation itself. So whenever the load is applied, so what is happening? Stress will be produced. Whenever that stress will be produced means we are not having any deformation. So that resisting the deformation, that property we are calling it as what? Stiffness. Okay. So it is resisting the deformation itself. We are not having any changes. But over here we are having the changes, deformation is occurring in the body, but it is resisting from where? From which point? Breaking point, failure point, it is resisting. So resisting the external load. Okay. So strength, stiffness we have completed over here. Now next point, let us discuss the next point. Now what is the meaning of ductility? What is the meaning of ductility? Now ability of the material, ability of the material to deform under tensile load. This is very interesting over here, ductility. What is the meaning of ductility? Means the ability of the material to deform. It is deforming, the body is deforming, but which load? Under which type of load? Under tensile load. Tensile load means what I have said you, whenever we are increasing, when there is an increase in the length of the body, that type of loads we are calling it as what? Tensile load. Okay. Now next, let us write some more points, but before that I am writing the definition for malleability over here. Malleability, ability of the material, to deform under compressive load. Okay, ability of the material to deform under what? Compressive load. Same part we are having, ability to deform, under which load? Tensile load. Under which load? Compressive load. Okay, so we have taken this part. Now over here, this ductile process, it is actually for what? Wire drawing operation. Wire drawing operation means what? What is happening over here? For making of wires. For making of what? Wires. Suppose we have taken the material like this. Now whenever we are applying the tensile load, what is happening? There will be increase in the length of the body. Increase in the length of the body. What is happening to the diameter? Diameter is decreasing. So whenever there is increase in the length of the body, decrease in the diameter, what is happening? There will be in the form of what? There will be in the shape of what? Wires. Okay. So that's why what we are writing over here, wire drawing operation, means we are making the wires with the help of which process, which property? Ductility. Okay. So that's why we have written this part. Now over here what we are writing means, metals are hammered and rolled into thin sheets. Now what is happening? We are taking the material, compressive load is in a compressive load. So that's why what we are doing? We are performing the hammering operation. So metals are hammered and rolled into what? Thin sheets. What we are making? We are making what? Thin sheets. And one more point we can write over here. We can write this part as all ductile materials. What we can write? All ductile materials. All ductile materials are malleable. are malleable, because we are having these ductile materials. Now whenever we are taking the ductile materials which are in wire shape, circular shape, wire shape, what we are doing now, we are performing the hammering operation and we are making into what? Thin sheets. Okay, what we are doing, we are performing the hammering operation on these ductile materials. Whenever we are performing that hammering operation, we are making what? Thin sheets. That thin sheets we are calling the property as what? Malleability. Okay, malleability. So over here ductile means which examples we can take? We can take the examples as aluminium. We can take what? We can take aluminium, we can take gold, we can take silver, we can take mild steel. Mild steel is most important. Okay, mild steel is most important. So we can take this example. Same examples we can take for malleability also, because that examples, that materials we are taking, we are hammering and we are making into what? Thin sheets. Okay, so this part is completed. Now after this we are having the property as resilience. What we are having? Resilience. So ductility, malleability is completed. Now what is the meaning of resilience actually? Resilience means ability of the material, ability of the material to absorb energy or else store energy, to store or absorb energy within the elastic limit, within the elastic limit. Okay, we have taken this part. Now similarly same definition we are having for one more property over here, that is we are calling it as toughness. What we are calling? Toughness. Like how we have written for ductility and malleability, similar definitions we have taken now. Similarly over here also what we have taken? We have taken resilience and we have taken it as a toughness. So in this part also what we are writing means ability of the material, to store or else absorb, energy before fracture. Last point we have taken away. Now listen here, what is the meaning of elastic limit and fracture over here? So both are also, it is having the ability to store, to absorb that energy whenever the loads are being acted. Suppose this material we have taken, whenever the loads are being applied, stress will be produced. So whenever that stresses, that loads are being applied on this material, so what they are having the ability, they are having the ability to absorb that energy, to absorb or store that energy. Up to which point? Now this is main point over here. So this resilience means what we have taken? Within the elastic limit. Now what is the meaning of this elastic limit actually? Suppose just now we have taken the example, now steel scale example we have taken. If we are applying the load, applying the force on this steel scale up to some limit, it will be coming back to the original position. Now again and again whenever we are increasing the load or force, means what will happen? After crossing some limit, if you are exceeding some limit over there, it is not coming back to the original position. So that limit, that maximum limit, we are having that part, that maximum limit. If you are crossing that maximum limit, means it is not coming back to the original position. If you are up to that maximum limit, means it is coming back to the original position. It is occupying that original position. Understood? So that highest limit, highest point, maximum limit, what we are calling? We are calling it as a elastic limit. So within the elastic limit, what is the energy storage, what is the energy absorption we are having? That property we are calling it as what? Resilience. Understood the point? Now similarly toughness means what? If you are crossing that elastic limit, which region will be there? Within the elastic limit, we are having the region as elastic region. What we are calling? Within the elastic limit, we are calling the region as what? Elastic region. If you are crossing that elastic limit, that region we are calling it as what? Plastic region. Just now we have discussed plasticity. Plastic region means what? It is not having, now it is not having the ability to come back to the original shape. So that region we are discussing now, plastic region. When we have crossed that elastic limit means we are entering into the plastic region. Now again and again whenever we are applying the load means what will happen? After some point over there also there will be starting of the cracks actually. The body or else the material will be begin to water, there will be cracking, then there will be breaking or else fracture we can see over there. Okay, so before that fracture, before that breaking point, whatever the complete energy storage we are having, that property we are calling it as what? Toughness. Okay, so this absorption of energy within the elastic limit only, but this toughness before fracture, before failure of the material, all that energy storage, energy absorption, it is called as what? Toughness. Okay, so till now what we have discussed about elasticity we have completed, plasticity we have completed, strength and stiffness combination we have seen, ductility and malleability combination we have seen, next resilience and toughness combination we have seen. Okay, now next let us discuss about hardness. Now what is the meaning of hardness over here? So ability of the material to resist abrasion or else scratching, etc. So now what is this property? Hardness means what? Ability of the material to resist abrasion, scratching, etc. Scratching, abrasion means what? Wear and tear will be there. So this material we are having again and again whenever we are applying the loads, which is normal or else parallel, perpendicular or else parallel to the cross section, whenever we are applying these types of loads on the material, what will be happening? There will be scratching on that materials or else wear and tear will be there on the material. So this hardness property, what is the meaning of hardness over here? It is having the ability which will resist this scratchings and the abrasion of the material of the body. So that property we are calling it as what? Hardness. Okay, so we have completed this hardness part also. Now next what we are having? We are having this next part as a creep. What is the meaning of a creep actually? What is the meaning of a creep? Creep is very simple. Slow and progressive deformation. Slow and progressive deformation of the material with time under constant stress, constant stress. This is called as what? Creep. Now what we have written the definition for creep over here? Creep means slow and progressive deformation of the material with time under constant stress. Now let us take one simple example over here. Which example we are taking means, suppose we are having the bundle, paper bundles we are having. So on that we have tied that papers with the help of the rubber band. Okay, we have taken the rubber band example. So now what is happening? As the time is passing over there, as a passage of time, what is happening? As a bundles, as a paper bundles we are having more, so the some type of load it has been acted on the rubber first. Okay, so slow and progressive, what will happen? Due to that load, constant load we are having, we are not increasing the load actually, due to that constant load of the paper bundle actually, what will be happening? As a passage of time, there will be a slow and progressive deformation in the rubber band. There will be small cracks will be generated in the rubber band. So as a passage of time, what is happening? Slowly the deformation it is increasing. Whenever the deformation is increasing as a passage of time, at some time what will happen? That rubber band will be coming to what? It will be fracture, it will be breaking. The rubber band will be what? It will be coming to what? Breaking point, it will be fracture. Understood? So this slow and progressive deformation we are having with time under what? Constant load or constant stress. We are not increasing, we are not decreasing the stress over here, same stress we are having. So as the time is passing, what is happening? There will be slow and progressive continuous deformation on that material, and after reaching some time, after reaching some point, that material or else the body will be in breaking condition, will fracture. Okay. Now one more point we are having over here, one more point we are having, that is a brittleness. Brittleness. Now what is the meaning of a brittleness? Ability of the material, ability of the material, ability of the material to fracture with very little deformation, with a very little deformation, or else what we can call it as a sudden breaking, with very little deformation we are getting the fracture. So this type of property we are calling it as what? Brittleness. Okay, we can take the example of the glass actually. What we can take? We can take the example of the glass, or else chalk will be then a chalk. So somewhat we are applying the pressure or load, means what will happen? It will be broken. Okay. So glass also what we are having? Suddenly breakable. So whenever the ability of the material to fracture with very little deformation, with very little amount of load or stress, that type of property we are calling it as what? Brittleness. Okay. So let us revise this part what we have studied till now. So first we have covered the elasticity, then next is plasticity, strength, stiffness, next part is ductility, malleability, next resilience, toughness, hardness, creep, brittleness. Okay. So we have completed the concept of this mechanical properties. Now we are going to solve the gate bits, ESC bits, TSPSC, APPSC bits, as well as other state bits also. Some of the bits are related to this concept. Okay. Now let us see our first question. What we are having? The property of a material by which it can be beaten or rolled into thin plates. What is the answer? What is the answer? Thin plates or thin sheets. Directly we have written this definition just now. What is the answer? We are having the answer as malleability. Okay, rolled into thin sheets. Thin sheets. Wire drawing operation means what? Ductility. Whenever we are hammering and rolling into thin sheets means malleability. So option 4 will be correct. Okay. Now next part, next question. Which one of the following materials is highly elastic? This also I have explained you. Which of the following material is highly elastic? Rubber, brass, steel, glass. What is glass? Glass is a brittle material. Yes or no? Rubber we are having, brass we are having, steel we are having. What we have written, the most important point, I have said you earlier only. What is the answer? Steel. Steel will be more elastic. Steel will be more elastic. That's why option number 3 will be correct. And this question is of AE 2012. Now next part what we are having, our next question is the property of a material to resist the deformation. To resist what? To resist the deformation under the stress. So what we have discussed this definition actually in the stiffness. Strength means what we have taken? Resisting the external loads before failure, before a fracture. But resisting the deformation under the stress means it will be related to what? Stiffness. Okay, stiffness we have done. Exact definition we are having. Now let us go for the next question we are having. In a linear elastic structural element, in a linear elastic structural element, what are the options we are having? Stiffness is directly proportional to flexibility. Stiffness is inversely proportional to flexibility. Stiffness is equal to flexibility. Stiffness and flexibility are not related. Okay. Now listen here carefully. So as we have studied stiffness, what is the meaning of stiffness actually? Stiffness means It is ability of the material to resist the deformation. Whenever it is resisting the deformation, we are calling it as what? Stiffness. Okay, resisting the deformation. Resisting the deformation means what? We are not having any changes. If we are not having any changes means what we can say in the other words, in the other terms, what we can say? Flexibility. What we can say? Flexibility. So whenever we are having the more stiffness, if we are having the more resistance to deformation, what we can say? We are having the more stiffness of the material. If we are having the more resistance to deformation, what we can say? We are having the more stiffness in the material. If we are having the more stiffness means what? What about the flexibility over here? Flexibility means what is happening? Flexibility means there will be changes in the body, there will be deformation in the body. So when we are having the more stiffness, we will be less flexibility. We will be having what? Less flexibility. More stiffness, less flexibility. Okay, so if you are having more flexibility means what will happen to the stiffness? Less stiffness. Understood? So how we can relate this part? Directly proportional or inversely proportional? So if you are having the more stiffness, less flexibility, more flexibility, less stiffness. So it is inversely proportional. So which option we can write over here? Option number 2. Okay, so in a linear elastic structural element, this question is of a GATE 1991 actually. So stiffness and the flexibility will be inversely proportional. Okay, so this part we have completed. Now next question what we are having? Cup and the cone fracture usually indicates the material as. Okay, now listen here carefully. So we have seen some different types of fractures we will be having. What are the options given over here? Elastic, brittle, ductile, plastic. So elastic region we are having, plastic region we are having, brittle means deformation, ductile means deformation. Okay, so we can find out easily from these two options one option will be correct. From these two options one option will be correct. Okay, brittle or else the ductile. So how will be the fractures of the brittle? How will be the fractures of the ductile? What we have discussed, brittle fracture, brittleness. What is the meaning of brittleness actually? Sudden breaking. Whenever we are having the sudden breaking means what we are calling? We are calling it as brittleness. Okay, so we can take some example of the chalk actually, chalk or else glass we can take. So whenever we are taking the example of the chalk, if you are suddenly applying some load means what is happening? It is breaking. So we can take this part as we are having like this. This is a chalk, and whenever we are applying some load means it is breaking like this. Okay, straight. So brittleness. So whenever we are having the brittle fracture, it will be straight actually. Understood? Now coming to next part. Suppose this part we have taken. This is a body we are having over here, and we have applied this body and we are having some fracture over here. So what is happening to the ductile material? Ductile material means what? Ductile material means we are applying the tensile load. Due to the tensile load, the body is deforming. So again and again it will be giving the warning that the body is getting to fracture. Okay, so what is the meaning of ductile over here? In ductile what we have discussed? We have discussed that the body, the ability of the material to deform under the tensile load. So the body will be deformed under the tensile load. So whenever we are increasing again and again tensile load, what will happen? It is giving the warnings that the body will be coming to breaking point. The body will be fracture. So it is giving again and again conditions, again and again warnings. So that warnings, that conditions, it will be look like. So again and again we are applying the tensile load means it will be like cup and a cone, So it will be like this. So this we can call it as a cup, and this part we are calling it as what? A cone. Understood? Or as reverse of that part also we can take cup and cone. So one part what we are having, one part it is in the shape of cup, and the other part we are having in the shape of what? A cone. It will be not exactly. We are having somewhat differences over here. Some again and again we are having again and again warnings we are getting actually. So whenever we are getting again and again warnings like this, so cup, the fracture will be in the form of what? Cup and cone. Okay, you have to remember this word actually. Cup and cone. This is most important. Cup and cone fracture, it is usually indicates that the material is what? Ductile. ductile, that the material is what? Ductile. Understood? Because brittle means sudden breaking we are having. Sudden breaking means we are having the straight fracture actually. Straight fracture we are having. In the tensile loads, again and again tensile load is applying, we are applying the tensile load. So it is giving certain warnings that the material will be having the fracture. So this type of fractures we are having actually. So this we are calling it as what? A cup and cone fracture, and it will be related to what? A ductile material. Okay. So this question we have completed. Now next question what we are having? The stress strain curve for an ideally plastic material. Ideally plastic material. Ideally plastic material means what? Ideal body. Ideal body means what we'll call actually? Ideal means so in this part also ideally plastic material we are having. So we can call it as a perfect. What we can call ideal means what? Perfect body, like that. Similarly over here also perfect plastic material we are calling. So which graph will be perfect, which is suiting for ideally plastic material? Ideally plastic material means perfect plastic material means only we are having the deformations, we are not having the stress actually. We are not having any stress, we are having only the what? Strain. If you are having only strain, if you are having only deformation, then that will be coming under what? Plastic material. Okay. So over here what we are having means stress is also increasing. This is stress, this is stress, y part, y axis we have taken it as a stress, and x axis we have taken it as a strain. So whenever the stress is increasing, strain is also increasing, stress is increasing, strain is also increasing over here. But after some point, the strain it is maintaining some constant level over there. Okay. In this part also stress and strain is maintaining. In this part also stress is increasing, decreasing, strain is also increasing, decreasing. But over here in the second graph, in the second option, what we are having? We are having the constant stress. What we are having? We are having the constant stress, and the strain is increasing. The strain is increasing. Understood? Over here stress is also increasing, strain is also increasing. Stress is also increasing, strain is also increasing. After some point strain is increasing over here. But what we have to take? Ideally plastic material, perfect plastic, only deformation. So at constant stress, what we have taken? We are having the values, we are having the increase in the strain actually. So when we are having that part means we can call it as a ideally plastic material. What we have to look means we have to see that at constant stress the strain should be more. At one point only, and one point of the stress the strain should be more. That will be coming under what? Plastic material. That's it. Okay. So second option is correct. Second option is correct. Now let us go for the next question over here. Next question what we have taken, match the list 1 and list 2 and select the correct answer using the codes given below the list. Okay, what we are having? Ductility we are having, brittleness we are having, tenacity we are having, and we are having the toughness. Okay, so just now we have seen the definitions of all this part. So ductility, brittleness, tenacity, toughness. Let us read this point also. What we are having? Failure without warning. In this part also we can get the answer. Listen here. Failure without warning means sudden breaking. Sudden breaking means which definition, which property? Brittleness. So for B we are getting the answer as what? 1. For B we are getting the answer as 1. That's it. Okay. Now next what we are having? Drawn permanently over great changes of shape without rupture. Next point what we are having? Absorption of energy at high stress without rupture. Absorption of energy, where we have discussed absorption of energy means resilience and toughness. Resilience and toughness. Resilience means within elastic limit. Toughness means before fracture. Okay, so over here we can see absorption of energy at a high stress without rupture. Without rupture means what? This third, it will be related to what? D. It will be related to what? Okay. Now next what we can say? This part we are having. This part, second point we are having. So drawn permanently over great changes of shape without rupture. So it is having the deformation. We are having the large deformation. So when we are having the deformation means it is coming under what? Ductility. According to this options what we are having, we are matching this one. Okay. Now what is the remaining part we are having? C, tenacity. Tenacity means what? It is related to tensile strength. It is also related to strength only, but which strength? Tensile strength. Tenacity means what we are taking? Tensile strength. Okay. Now let us see this part. A, B, C, D we have taken. A means what we are having? A means 2. A means 2, these 2 options we are having. B means what? B means 1, B means 1. So if you are seeing this one option only, if you are seeing the one option only, brittleness means 1. So B means 1. Directly we can select this option. We no need to go for other options also. No need to go for other parts also. Only for brittleness what we have taken, failure without warning, we have seen in the options. So B means 1 we have taken, and we have selected the 4th option. Understood? Is it clear? So in this match the followings, you have to be very careful. First, one by one you have to check the options over here. If you are getting the direct answer, means directly we can select the option. Okay. So this was the concept of the mechanical properties which will be used in the simple stresses and strains for the civil students. So we have completed the concept as well as we have seen the gate bits, ESC bits, TSPSC, APPSC and the other state bits also. Okay. Now, SAIMEDHA, as I have already told you, SAIMEDHA Koti Hyderabad will be giving the online platform, online coaching for the civil, EC and the EEE students. Now, what will be included in this online coaching actually? Online coaching means what we are having? We are having the digitally recorded videos. Okay, with this digitally recorded videos we are having, what we are providing all the gate bits, we are providing all the ESC bits, we are providing all the TSPSC, APPSC, UPSC, all this different bits with the explanation, all the bits we are providing over here. Okay, and all the daily we are giving to we are providing the schedule actually. As per that schedule you have to prepare for that subjects. Is it clear? So now, as if you are seeing the other institutes, other coaching centers, they are charging nearly 50,000 for this polytechnic lecturers or is the similar type of government examination coachings actually. But we, SAIMEDHA Koti Hyderabad, we are providing this polytechnic lecturer coaching, online coaching only for, actually the fees is for 15k, but for starting 100 students, 100 coupons we are giving over here. For starting 100 students, 100 coupons we are giving, and we are giving this course only for 6,999. Understood? Only for 100 coupons, starting 100 students, we are giving this course for 6,999. So don't waste your time. Hurry up, take this, avail this opportunity actually, and prepare well for your examination. Thank you very much.